Hi, I'm Miss Van Loan, and in this video, we're going to complete Module 1, Lesson 8, Independent Practice. Remember, I recommend using your math notebook and using your paper the normal way, which is called portrait. Please use a pencil, either number 2 or mechanical, and have an eraser handy. For the purposes of this video, I will be using a blank sheet of white paper, and it will be in the landscape orientation. That is because it works better for the video camera. I'm also going to be using pen because it shows up better on camera. All right, let's get started. All right, let's do Module 1, Lesson 8, Independent Practice, and please put your name. All right, number 1. Of the following, which is closest in value to 0.68, how do you know? So closest to 0.68, how? Okay, so A says 2/3, B says 1/2, C is 3/5, and D is 3/4. So sometimes you'll understand that there are different ways of doing this, and you kind of want to ask yourself, what is the point? What are they trying to see that I know how to do? And for this lesson, it is double checking that you remember how to do long division and that you know how to do long division with decimals. So since we can look back at the lessons in Module 8 and see that that's what it's testing us on, then that's what we're going to do for these. We're going to do long division to find the decimal. So remember that the number on top goes inside the house, and the number underneath goes outside. So this is 2 being divided by 3. 2 is being divided by 3. So 3 doesn't go into 2, not as a whole number at all. So we're going to have to put a 0, put a, I just forgot what that's called. Put a period, and then add some zeros. We'll see how many zeros we're going to need to add. And then we're going to put it up there as well. We just carry that decimal, that's the word. We just carry that decimal straight up. Okay, so now let's look at 20. We're going to look at this whole thing right here, 20. So 3 times, well, okay, 0 times 3 is 0, and then 2 minus 0 is 0, and then we bring the down, and then, sorry, 2 minus 0 is 2. Oh boy, I should just start over, huh, at this point. Okay, 2 minus 0 is 2. Bring down the 0. We've got 20. All right, so how many times does 3 go into 20? Well, 3 times 7 is 21, so we're going to have to go one below that. That would be 6. 6 times 3 is 18. 20 minus 18 is 2. Bring down the 0. We've got 20 again. Look at that. That was 20. Okay, well, again, 6. So 6 times 3 is 18, and then we have 20 minus 18 is 2. Bring down the 0. We've got 20 again. Do you think it's going to keep happening? Do you think it's going to happen again? All right, so 6 times 3 is 18. 20 minus 18 is 2. We'll put another 0 here, bring that down. 20. Okay, so 20, 20, 20, 20. Well, you know, again, 6 times 3 is going to be 18, and I'll be left with a remainder of 2. And no matter how many times I do this, I'm going to keep getting that result. That's because 2 divided by 3 gives us a repeating decimal of 0.66666666666. It just keeps going forever. It is a never-ending decimal, a non-terminating, right? To terminate something is to end it. So a non-terminating decimal, 0.6666, and we could put some dots here to show it goes on forever. The other way to write this would be 0.6 with a bar over it to show that the 6 is repeating forever. And if we were to round it, it would be 0.6, however many sixes, and then round the last one up, because if we round it to the tenths, it would be 0.7. If we round it to the hundredths, 0.67. If we round it to the thousandths, 0.667. Okay, I think you get the idea. 10 thousandths, 100 thousandths. So whatever the problem tells you to round it to. All right, 1 divided by 2. Do you know what 1/2 is as a decimal? If you don't, you should. You should memorize that. But well, if you forget, you can always double check. So 1 divided by 2, 0 times 2 is 0. 1 minus 0 is 1. Add our decimal. Add a 0. Okay, bring that down. We've got a 10. 2 times something is going to give us 10. It's 5. So 5 times 2 is 10. We have a remainder of 0. So our decimal is 0.5. That's why I'm saying you should have it memorized, because 1/2 is the same as 0.5, which is the same as 50%. They're all half. All right, 3/5. So we have 3 divided by 5. So we'll put our 0 there. 0 times 5 is 0. 3 minus 0 is 3. Let's put our decimal, carry it up, put a 0, bring the 0 down. 5 times something will give us 30. That number is 6. 6 times 5 is 30, and we have a remainder of 0. So 3/5 is equivalent to 0.6, and it's not repeating. It ended. It terminated. This is a terminating decimal, not a repeating decimal. 3/4. That's another one kind of like 1/2, where if you know, you know. But let's say you don't know, so we'll do 3 divided by 4. 0. 0 times 4 is 0. 3 minus 0 is 3. We'll put our decimal, put some zeros in here. I know I'm going to need 2 because I already know what the answer is. All right, so bring down the 0. 4 times something will get us close to 30. 4 times 8 is 32. 4 times 7 is 28. So 7, 28. 30 minus 28 is 2. Bring down the 0. Uh-oh, are we going to get 20? Is it going to do what this thing did? No, it's not going to do that, because 4 times 5 is 20. 5 times 4 is 20. There's no remainder. 3/4 is the same as 0.75 or 75%. Okay, so we've got our work that we did here to figure these out. Now we've got to go back to the original question. Which one is closest to 0.68, and how do we know? Well, this one is 0.6 repeating. That's pretty close. 0.6 is close to 0.68. 0.5, nah, that's way off compared to this one. This one's way closer. 0.6, I would say that 0.6666 is closer than 0.6, right? 66 is closer to 68 than 60. We could put a 0 here, right? This is like 0.60. 75 or 0.75. That's over and above 0.68. 0.66 is closer. So A is going to be our answer, but we still have to answer the second part of the question. How do we know? So we'll put it down here below the work that we did. So let's put it right here. A, 2/3 is closest to 0.68 because 2/3 is equal to 0.6666 ... right? It's repeating. So there's our answer. Kind of took up a lot of the page because of all of our long division, but that's okay. It's good practice. You need to know how to do that, especially if you don't have a calculator and you go to take a test at some point in the future and you need to know how to do this. It's a really good refresher. All right, number 2, which is the proper way to record the decimal version of 2/3, which is proper decimal of 2/3. And we just talked about that. That's A. See if you guys remember. So A is 0.6, B 0.66, C 0.67, or D 0.6 with a bar over it. Do you remember? It's this one with the bar over it. That's actually the proper way to record the decimal for 2/3. When you have a repeating decimal, the bar goes over whatever number is repeating, or whatever set of numbers are repeating. All right, let's do number 3. I'm going to kind of do this sort of thing here to separate my page. Okay, number 3. Haley rode her bike 4/5 of a mile to the park. What is the distance she rode expressed as a decimal? So really all we need is the number 4/5 as a decimal. So again, it wants us to practice long division, so that's what we're going to do. 4 divided by 5. I'm going to kind of skip straight to this part here, 0 point. So 5 goes into 40. What times 5 will get close to 40? 8. 8 times 5 is 40, and a 0 remainder. So the decimal is 0.8. Okay, let's do number 4. Ben scored 21 out of 25 on his science quiz last week. How do you express his score as a decimal? 21/25 as a decimal. So 25th is actually 1/4 of 100, right? I mean, we could do this using long division, but I see a quicker way. I see an easier way. I could have used this method I'm going to show you on here as well, but I thought that the decimal was pretty easy. I'm going to show you this. So if you can get your fraction over 100, you can write your decimal as 100ths. Let me show you what I mean. So 21 over 25, I'm going to multiply by the big 1. So if I have a big 1, I have to multiply the same thing on top by the bottom. And what I want to get is I want to get 100 on the bottom. So what do I multiply 25 by to get 100 on the bottom? I multiply by 4. So if this is a giant 1, remember if you multiply by 1, it keeps its same value. So this is a giant 1 and I have a 4 on bottom, I have to have a 4 on top. So 21 times 4, 20 times 4, here we'll do a generic rectangle again. I love these, it helps me do mental math. So I have a 20 in the tenths place and I have a 1 in the ones place. So 4 times 2 is 8, and put the 0. 4 times 1 is 4. So now I have 80 plus 4, which is 84. So now I have 84 hundredths. That's the same thing as 0.84. This is the tenths place. This is the hundredths place. So 84 hundredths as a decimal. Let's do number 5. Bethany has read 13 out of 20, 13 twentieths of the book that was assigned for class. Express the portion she has read in decimal form as a decimal. I think I'm going to use this method again and get hundredths and then express it as a decimal in hundredths. So, because, I mean, I could do it where I do 13 divided by 20, but personally, I don't really like having a double-digit number on the outside of a division, a long division. I don't know why, I just don't. So let's do it as this way, 13 over 20 times some giant 1 is going to give me some number on top over 100. So 20 times what will give me 100? Look at the tenths place here. 2 times something, if we get rid of this 0 here and this 0 here, 2 times something will give me 10. And then we could put the zeros back on. 2 times what gives me 10? 5. So 20 times 5 is 100. So then we use our giant 1. So 13 times 5 out of 100. So I'll use my generic rectangle here. 5 times 13. I've got a 10 in the tenths place and a 3 in the ones place. 5 times 10 is 50. 5 times 3 is 15. Put it together, we get 65. So this is 65 hundredths, which means my decimal is 0.65 or 65 hundredths. Okay, number 6. A store is advertising a sale with 1/3 off all original prices. What is the decimal form of this fraction? 1/3 as a decimal. So we cannot get to 100 easily with a 3. We're going to have to do long division here. And that's okay. 1 divided by 3. So I'm going to kind of jump ahead here. 0 point something. Okay. 3 times 3 will give me 9. 3 times 3 is 9. And I have 1 left over. Add a 0, bring it down, 10. 3 times 3 is 9. I have 1 left over. Add a 0, bring it down, 10. Uh-oh, do you see what's happening? Besides me, like, maybe running out of ink. We're seeing 10 again, and then 10, and then 10. 3 times 3 is 9. We have a 1 left over. And then if we add another 0, bring it down, 10, and we're going to get another 3, 9, 1. So we've got a repeating decimal here of 0.33333333, ... It just keeps going. So we're going to use this method where we put a little bar over it. It's 0.3 with a bar over it. It's a repeating, never-ending 3. Okay, let's move on to number 7. Number 7 says, what is the decimal form of 5/8? Is it repeating, terminating, or neither? So 5/8 as a decimal, repeating, term, or neither. Okay, that's my way of reminding me that there's a second part of this question. All right, 8 does not multiply up to 100 very easily either, so we're going to have to do long division. 5 divided by 8. So we'll already start with our decimal and our 0. 8 times something to get close to 50. It's going to be 6. 6 times 8 is 48. So 6 times 8 is 48. And I have 2 left over. 50 minus 48 is 2. Let's add a 0, bring it down. That's 20. 8 times 2 will give me 16. So 2 times 8 is 16. I have a 4 left over. 20 minus 16 is 4. Put a 0, bring it down. 40. So now 5 times 8 is 40, and I have a 0 remainder. So the decimal is 0.625. Nothing's repeating, and I wound up with a 0 at the end, 0 remainder. So it is exactly 0.625, or the other way of saying this is 625 thousandths. This is the thousandths place, so 0.625, 625 thousandths. All right, and then we will say that it is terminating because it does not repeat and it does end. All right, let's look at number 8. Mr. Miller stated that 5/6 of the students would be going on the field trip. Elena says that is the same as 0.83. Francis disagrees and thinks it's the same as 0.83 repeating. Margot says they are both wrong and thinks it's the same as 0.83 with just the 3 repeating. Who is correct? Why? How do you think the other 2 people arrived at their answers? All right, so this one's kind of long. It's got a lot of questions in there. But we're going to say 5/6 as a decimal. And then we're going to say Elena says that's 0.83. Francis says 0.83 with both the 8 and the 3 repeating. And Margot says it is 0.8 with just the 3 repeating. So the bar goes over just the 3. Who is correct? Why? And how did they get their wrong answers? So who, correct, why, how, wrong. Okay. So a lot to answer at the very end here. So 5/6. So 5 divided by 6. 6 doesn't multiply up to 100 easily. So 5 divided by 6. So 5, let's just put our 0 and our decimal in. So let's see, 6 into 50. 6 times 8 is 48. We just had that one. So 8 times 6 is 48. We have a 2 left over. Add a 0, bring it down, 20. Okay, so 6 times something will get close to 20. It's going to be 3. 3 times 6 is 18. And we have a 2 left over. 0, bring it down, 0. 20. Okay, 3, 6. So 3 times 6 is 18. And we've got a 2 left over. Wait a minute, we're getting a repeating here. See this repeating pattern? 20 minus 18 is 2. 20 minus 18 is 2. We're going to bring down another 0. We've got 20. We're going to put another 3. We'll get 18. We'll keep getting a remainder of 2 forever and ever. So it looks like, who is correct over here? So it's definitely repeating. So Elena was wrong. Francis was wrong because he put the bar over the 8. The 8 doesn't repeat. So Margot's the one correct because it's just over the 3. Because just the 3 is repeating. So who is correct is Margot. Why just the 3 repeats? How did they get their answers wrong? Elena forgot it was repeating. Francis forgot it was just the 3. That repeats. And there is my answer. Okie doke. Let's do number 9. 9. Is 9 over 11 a rational number? Why or why not? Well, rational has the word ratio. A ratio is a comparison. And a ratio or a comparison can be written either as a fraction, as certain types of decimals, or sometimes we see it like in like a game score, like 2-to-1, something like that. So all fractions are ratios because it's a comparison of 2 numbers. So is it a rational number? Yes. 9/11 is rational because all fractions are ratios. Okay? I think that this question might have wanted us to divide it out and see if it was a repeating or terminating decimal, but that's extra work that isn't even necessary if you know the definition of rational, that it's any ratio. So all fractions are ratios. And actually whole numbers, because you can say like a whole number 5, you can be like, oh, well, that's 5 wholes, 5 ones. So a whole number is going to be rational also. So what is irrational is going to be something that never repeats and goes on forever. So like the number pi is irrational. You know, pi goes on forever and ever and ever, and it never repeats. 3.14159, blah, 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 to infinity. All right, let's do number 10. Jonah used a calculator to determine the decimal form of the number 5/9. So calculator says 5/9. Another eraser moment, but I'm using pen for the camera. Calculator says 5/9 equals 0.5555. Oh my gosh, how many 5s are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the 10th number is a 6. 1, 2, 3, 4, 5, 6, 7, 8, 9 5s and a 6. Okay, Jonah used a calculator to determine the decimal form of the number 5/9. He wrote the answer 0.555555556 on his paper. Is Jonah correct? What do you think happened? Okay, so think about a calculator. Think about how when you enter a number on it, it only has a specific size screen. So at some point, it's got to cut off the number. So on this calculator, it had a pretty wide screen because it allowed 10, 11 digits and a decimal. So what happened over here? What do you think? Do you think maybe this is the exact number that it is, let's see, 10, 100th, 1000th, 10,000th, 100,000th, millionth, 10 millionth, 100 millionth, billionth, 10 billionth? Do you think that 5 divided by 9 is goes down to the 10 billionth of a number? And this is it exactly. Yeah, I don't think so either. I think it's a repeating 5. Would you guys agree with me that the answer to 5/9 is going to be a repeating 5? So 0.5 repeating. We'll put a little 0 in there. 0.5 with the 5 repeating. So yeah, I think that's what it is. I think it's 0.5. I'll put it down here. 0.5, and the bar is over the 5 because the 5 is repeating forever. So what happened then? What did the calculator do? It rounded up. And it rounded up because 5 and up, you round up. If it was 0.3333333333333, we wouldn't see it rounded up because 3 is less than 5, right? So if a calculator, you know, maybe it was 1/3 and the calculator was like, oh, well, that's 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Does it end there? No, it still keeps going. The calculator just rounded, but it rounded down, or it didn't round up because 3 is less than 5. So the question says, is Jonah correct? What do you think happened? Jonah is not correct. He forgot that 5/9 has a repeating decimal equal 0.5 repeating. What happened? The calculator rounded the last 5 up to a 6. Okay, Jonah is not correct. He forgot that 5/9 has a repeating decimal. It equals 0.5 repeating. The calculator rounded the last 5 up to a 6. And there we go. We are done with this one. Yay! Thanks, guys. Let me know if you have any questions.